Okay, so my name is Bilal, and today we'll be solving additional mathematics Feb March 2024 variant 1 2, that is of 2 hours and it is of paper 1. So now moving on. Now before we start, please do like, share and subscribe our channel. We're starting with question 1, which is given that y is equals to 2 plus 4 cos 3 theta for minus 1 negative 120 till 120. Write down the amplitude of y. So for the amplitude of y, we consider this equation, and whatever is multiplied by cos theta is our amplitude. So this 4 is our amplitude. 4 is our amplitude. Now, next question is write down the period of y. Now, for the period of y, this tells us about the period of y. So for a cos theta function, the period of cos theta is basically 360 degrees. But here we have cos 3 theta. So we will have 3 waves in 360 degrees. So we'll have our period as 360 divided by 3, which is equals to 120 degrees. So this would be our period. Final answer. On the axis, sketch the graph of y. So we need to draw the graph of y. And our y is, let's write it down here, y is equals to 2 plus 4 cos 3 theta. So this 2 is our main line, this is our axis, which we consider it as 0 if we don't have this. So we'll be starting with 2 as our base and 4 as our amplitude. So 2 and then 4 added would be this. Then since it completes at 120 degrees, so this would be 120 degrees. Again this 60 will have 60, at 60 will be having negative 4 negative 4 as our amplitude, so this would be this, and in between, that is 30 degrees, this would be 30. Our graph would be cutting 2, and after 60 would be 90, so this would be this. So we'll be drawing our graph as something like this, and same for the other part. This would be this, then this, so this would be our complete graph. Now moving on, we have our question 2 as given that LG log PA plus log P12 negative log P6 equals to 3 log P4. Now we'll be applying product law, quotient law and everything, the power law, everything all together. So we'll be writing this as one single log. We'll write this as log P. This A will be multiplied by 12 because these two logs are added. So we'll be using product law here. So this would be 12A. This is negative, so this would be divided over 6. This would go in the power of 4. So this would be log P 4 power 3. This log P and log P would be cancelled out. This would be 2A. 4 power 3 is 64. This would be 2A, and our A would be 32. So this is our final answer. Now moving on to part B, we are given that find the exact solution of the equation 4 log 3x is equals to 9 log x3. So we can write this as 1 over log 3x. This is the inverse log law. So this would be written as 4 log 3x equals to 9 multiplied by 1 over log 3x. So this log 3x would be multiplied over there, and this 4 would be divided. This would be log 3x whole squared is equals to 9 over 4. So this would be square rooted on both sides. So this would be log 3x equals to plus minus 3 over 2. So our final answer would be x equals to this 3 will have the power of this. So this would be 3 plus minus 1.5. 3 over 2 can be written as 1.5. 5. So this would be our final answer since it was a exact solution. Now moving on, we have our question 3 as the curve C has equation y is equals to ln x cube plus 3. The normal to C at the point where x equals to 1 meets the line y is equals to x at the point P. Find the exact coordinates of P. So we are given with x equals to 1. We can calculate our y by plugging in the equation, this equation. So we'll get our y as ln 1 cubed is 1 plus 3. So this would be ln 4. So we have our x and we have our y. Now let's calculate the differentiation. That would give us the gradient of the tangent. Now and then we'll be inversing it, inverse reciprocal it to get our normal's gradient. So this would be this differentiation would come in the denominator. It would be 3x squared. X cubed would be powered, will be coming next. This would be 3, and then power would be decreased. This would be 3x squared, and then the whole function would be coming in the denominator. So this would be x cubed plus 3. This would be our final differentiation. We are given as x equals to 1. We'll be plugging in x as 1 here. We'll be getting it as 3 over 4. So this is the gradient of tangent. Gradient of tangent. For gradient of normal, we'll be uh, using this formula. So this would be negative 1 over 3 over 4. So this would be finally written as negative 4 over 3 as our normal gradient. Normal's gradient. So we have our equation as y is equals to negative 4 over 3 x plus c. We had our x as 1 and y as ln 4. So this would be negative 4 over 3 into 1 and equals to ln 4 plus c. Our c would be ln 4 plus 4 over 3. And we can write our equation as we have our, since these two lines meet, so this would be y equal to x. We can write this as x. So this would be we will be getting it as x equals to negative 4 over 3 x plus this c. This would be ln 4 plus 4 over 3. Now let's just move this x over there, or this can be moved over there. So this would be x plus 4 over 3 x. This is moved over there and this would be here. So this would be ln 4 plus 4 over 3. We'll get our final x as 7x over 3 ln 4 plus 4 over 3. This 3 will be multiplied over there. So this would be ln 3 ln 4 plus 4 equal to 7x. 3 ln 4 is basically ln 64. Power would be going up. So this would be ln 64 plus 4 over 7 is our final answer. So this is our final answer. Now since this is our x, the same would be our y as well, because we had our y is equals to x equation. So this would be our y as well. We can write the coordinates. You can write the coordinates as the same, ln 64 plus 4 over 7. This would be our x and this would be same as a y. So this would be the coordinates. Now moving on, we have our question 4 as a function. F is such that f of x equals to 2 plus e power negative 3x. We need to write down the range of f. So if we look closely, we can write this as 2 plus 1 over e power 3x. So if x approaches to infinity, we get this as 0. But something would be added over here. So this would be, we have our f of x as greater than 2 always. And if x is negative infinity, so this would be positive and this would be added over here. So this e power 3x would be added. Now in part B, we need to find an expression for f of inverse of x. So for that, we can use the y formula, that is this, that looks like this. So now here we need to make x as the subject to get our f inverse. So this would be 1 over e power 3x. This 2 would be negative over there. So this would be y minus 2. This would be exchanged. So this would be 1 over y minus 2 equals to e power 3x. ln will be applied on both sides. So this would be 3x equals to ln 1 over y minus 2. This 3 would be divided. So we'll be getting our inverse as 1 over 3 ln y minus 1 over y minus 2. So this would be our f of inverse of y. You can substitute the y as x, so we'll get our f of inverse of x. Now in part C, we have on the axis, sketch the graph of y is equals to f of x and y is equals to f inverse of x. Stating the coordinates of the points where the curves meet the coordinates axis, state the equations of any asymptotes, label your curves. We have to now label the curves as well. So we concluded that f of x has to be greater than 2. So let's just take 1, 2, and then 3 over here. So this would be looking something like this. Since we need to make f inverse of x as well, so we'll be taking each and everything. So f of x needs to be greater than 2. So this would be something like this. And we need to calculate where it would be meeting y. So we can substitute x as 0 over here. So this would be 2 plus e powered 0 would be 1. So this would be 3. So here it would be meeting, and then since 2 is the asymptote, our graph would look like something like this. So this is our f of x. Now let's draw f inverse of x with a different pen. So this would be completely opposite of this. Since it's meeting at 3 here, so this would be here, and then this will be our asymptote over here. So this would look something like this. So this is our f inverse of x. So this is our final graph. Now moving on, we have a function g is such that g of x is x powered 3 upon 2 plus 4. Find the exact solution of the equation g of f of x equals to 12. Now for that we need f of x. We have our f of x as 2 plus e powered negative 3x. So this would be written as 2 plus e powered negative 3x powered this 3 over 2 plus 4 equals to 12. X is replaced by the f of x. So we'll be solving this. This 4 will go there. So this would be 8, 2 plus e powered negative 3 over 3x. This is 3 over 2. We need to remove this power. So we'll be multiplying this power by 2 over 3, and this would be multiplied by 2 power 2 over 3 over here as well. This would be cancelled out, and we'll get this as 2 power 3 is 8. So this 3 and 2 power 3 would be cancelled out. So we'll get our answer as 4 over here. So this would be 2 plus e power negative 3x. This 2 will go over there. So this would be e power negative 3x and then equals to 2. Then we'll be solving this. So this would be e power 3x equals to 2. This would go over there, and this will be multiplied over here. So this would be 1 over 2 e power 3x. Applying ln on both sides. So we'll be getting it as ln 1 over 2 3x. This 3 would be divided. So ln 1 over 2 and then 1 over 3 equals to x. So this is our final answer. Now moving on, we have our question 5 as The polynomial p is such that p of x equals to 5x cube plus ax square plus 39x plus b, where a and b are constants. Given that x plus 3 is a factor of both p of x and p of dash of p of uh, differentiation of p of x, find the values of a and b. Now it's easy if we calculate the p of differentiation of p, because when we calculate the differentiation of p, this p is cancelled out. We'll be having only a single unknown, that is a. So let's calculate p differentiation of p of x. So this would be multiplied, this would be 15x squared plus 2ax plus 39. And since x plus 3 equals to 0 is a factor, so x will be substituting x equals to negative 3 over here. So we'll be getting it as, getting the answer as negative 3 squared is 9. This is negative 3. This is positive 39 equals to 0, since this is a factor. So our remainder would be 0. So we'll be getting our a as negative 6a. This is we get this as 135 and this is 39. These both will go over there, so this would be 174. This would be negative, this negative and this negative would be cancelled out. We'll get our a as simply 29. Now we can substitute this in the next equation as well. So we'll be using p of x now. Our p of x is given as, we'll be substituting x equals to 3, x equals to negative 3 in p of x directly. So this would be 5 negative 3 whole cubed plus negative 3 whole squared a plus 39 negative 3 plus b equals to 0. This would be negative 135 plus 9. A is given as 29, so this would be 29. This would be negative 117 plus b equals to 0. Now if we solve this and then bring this over here, so we'll be getting our b as negative 9. So this is our final answer. We get our a and b. Now we have in part b as, hence solve the equation p of x equals to 0. You must show your working. We have to show our working as well. So let's just complete our long division over here. I'll try to do it. So this would be looking something like this: x plus 3. This is 5x cubed. Our a was 29. This is 39x negative 9. Then we'll be, to get our 5x cube, we'll be multiplying this as 5x squared. So this would be 5x cubed plus 15x squared. This would be multiplied by negative, so this would be negative, and we'll be getting our answer as 14x squared. This would come down as 39x. So for 14x square, we'll be multiplying this by 14x. So this would be 14x squared plus 42x. This would be negative. This would be cancelled out. This would be negative. So we'll get our answer as 3x, negative 3x. This would come down. This would be negative 9. Now for negative 3x, we need to multiply it by negative 3. So this would be negative 3x, negative 9. This would be multiplied by negative. So these two will be cancelled out. So we'll be getting our answer as x plus 3, 5x squared plus 14x minus 3. Now we need to solve this equation as well. So for this, we have our 5x squared plus 14x minus 3. You can use the calculator over here, or you can use the middle term break method. For middle term break method, we'll be using 15 and plus 15 and negative 1 as our factors. So this would look something like this. Negative 1, x plus 3 equals to 0. This would be 5x minus 1, x plus 3. This x plus 3 is repeated. So I will get our answer as x equals to negative 3, and our x would be 1 over 5 by solving this. So we get our answers as this. Now hence, using your values for a and b, solve the equation this. You need to solve the equation this. Now if you look at it, look at this equation closely, This is similar to this equation. So we need to simply substitute it and solve it. So we can say that our x is basically equals to cosec 2 theta. Now if we replace our x as cosec 2 theta, we'll be getting the same equation as this. And our cosec 2 theta can be written as 1 over sine 2 theta. Alright. So we have 1 over sine 2 theta as negative 3 and 1 over sine 2 theta as 1 over 5. Now for we'll be multiplying and dividing it by this. So this would be 1 over negative 3. So this would be sine 2 theta. And this negative sine negative is basically in third and fourth quadrant. So and then we'll be multiplying this by this, and this would be 5 is equals to sine 2 theta. This would be rejected since sine lies in between negative 1 and positive 1. So this will be rejected. We have our this equation, so we get our alpha as by using sine inverse 1 over 3. We get our alpha as 19.47. So we'll be getting our 2 theta as 199.47 by adding 180 to this figure and subtracting this figure from 360. We're getting it as 340.53. Since it's 2 theta, we can take the next rotation as well. This means adding 360 to it. So this would be 559.47, and adding 360 to this, we're getting it as 700.53. Now dividing all of these by 2, so we'll be getting our final answer as 99. Our theta as 99.7, 170.3, 279.7, 350.3 as our final answer, since our range was this. Now moving on, we have our question 6. In this question, all distances are in meters and all times are in seconds. The diagram shows the velocity time graph of a particle traveling in a straight line. The particle travels a distance of 2750 meters in 120 seconds. Find the velocity v of the particle when t is equals to 70. Now we know that for distance we need to calculate the area under the graph. So we have this area and we have this area. This is basically a rectangle. This is a trapezium. And this is our triangle. Alright. So this is the equation. We need to calculate the rectangle's area, trapezium's area, and triangle's area. So for rectangle area, we can multiply 10 by 30. So this would be 10 multiplied by 30. For trapezium, we need the height. Our height is basically this, and this is basically 40. This is 40. We need the two parallel sides. We need this. This is 10. And we need this. This is V. And for triangle's area, we need base into height. We have our height as V, and we have our base as 50. And this is equals to 2750. This 300 can simply be subtracted over there, and this 2 would be cancelled out. This 2 would be cancelled out. Sorry, by this. We're getting our final answers as 200 plus 20V plus 25V equals to 2450 by subtracting 300 from there, and then 200 would be subtracted. We'll be getting our final answer as 2250, and this would become 45, and this 45 would be divided. So we'll be getting our final V as 50 meters per second. This is our final V. Find the acceleration of the particles for 70 till 120. This here till here. So this is basically 70, 50, and this is basically 120 comma 0. We need to calculate the gradient over here. This would be 0 negative 50 and then 120 negative 70. So this would give us as 50 over 50, and this would be negative 1 meters per second square. We have our part B as a different particle moves in a straight line such that its velocity v meters per second t seconds after leaving a fixed point O is given as this. Find the exact acceleration of the particle when t is equals to 2. We need the exact acceleration of the particle when t is equals to 2. Now for the acceleration we need to differentiate our velocity. So this would be, we'll be using product law over here, using product law. So this would be given as t squared plus 5 powered 1 over 2, sorry. This would be our v and this would be our u. So we can write this as u v u dash plus u v dash, or alternatively this can switch over here, then this can go over here. We'll be using this. So our v is t squared plus 5 powered 1 over 2 multiplied by 1, this differentiation, and we have our u as t, and we'll be using this differentiation. This 1 over 2 would be coming down, this would be like this, and this would be negative 1 over 2, and we'll be multiplying the differentiation of this. This would be something, this would look something like this. Now we have t as 2, we'll be substituting t is equals to 2 over here. So we'll be getting it as 3 squared, 2 squared is 4, 4 plus 5 is basically 9, 9 powered 1 over 2 is 3. And then t squared, this would be t squared, so t squared would be 4. And this is basically in the denominator, so this would be 3. So we'll be getting our final answer as 13 over 3. Sorry. This is our final answer. Explain why the particle does not change the direction for t greater than 0. T has to be greater than 0 because the time can't be in negative direction. So if we take the t as positive, the velocity will always be positive. So we can write this as, because there is no change in sign for velocity as the t increases, so the particle does not change its direction. So this is basically our answer. Now moving on, we have our question 7 as find the integral of this, giving your answer in the exact form. It needs the exact form. So we'll be using the calculator least in the least amount. So this would be 5x minus 2 powered negative 2 over 3. So this powered would be added, and this would be 5x minus 2 added by 1. So this would be 1 over 3. This power would go in our denominator, and this would be 1 over 3, and its differentiation would be multiplied in the denominator. So this would finally become as, will be written as 3 would be going upward. So this would be 3 multiplied by 5x minus 2 powered 1 over 3 over 5, and we'll be applying our limits as 4 and 2. So by applying the limits as 4 and 2, we'll be getting our answer as 3. 4 into 5 is 20, minus 2 is 18, powered 1 over 3 divided by 5, negative, because of the upper limit minus lower limit, our lower limit would be 3, 8 powered 1 over 3, 5. So this would be 2 powered 3, and this would be cancelled out. So we'll be getting our final answer as 3 power 5 would be taken as common. This would be 18 powered 1 over 3, and then this is left as 2. So this would be this finally. So this is our final answer. Now we have to calculate, find for the integral of this equation. Find the integral of this equation, giving your answer in the form a plus ln b, where a and b are the integers. So for that, we need to calculate, and first of all we need to evaluate the integral. So for this, if we look at it closely, we have our function over here and we have our differentiation over here. So this would be, if we take 2 as common over here, so this would be 2 2x plus 1. This can be written as this, something like this, and then integral of 8. Let's just solve this separately. We can write this as 8 powered 8 into 2x plus 1. We can just take 8 outside as well. This would be negative 2. Now by solving this, we'll be getting this as 2. This is our function and this is our differentiation. So this would be ln 2x plus 1. We have our 8 as outside, and this would be, the power would be added over here. So this would be 2x plus 1 power negative 1. This would be negative 1 over here, and differentiation of this would be coming in the denominator. So this would look something like this, and this would be this. So this would be 2 ln 2x plus 1 negative 4 2x plus 1 in the denominator. So this will be applying our limit as 1 over 2 and 0 over here. So this would be 2 ln 1 over 2, and 2 is 1 basically. So this would be ln 2, and then this becomes 2, and then 4 over 2 is basically 2. This is our upper limit. Our lower limit would be ln 1, 2 ln 1, which is basically 0, and then negative 4 over 1. So this would be 2 ln 4 negative 2. This would be plus 4. So this can be written as finally as ln 4 plus 2. So this is our final answer. Now moving on, we have our question 8 as a 5-digit number is to be formed using 5 different numbers selected from 1, 2, 3, 4, 5, 6, 7, 8, 9. No digit may be used more than once in any 5-digit number. Find how many 5-digit numbers can be formed. So for first we have 9 combinations. For the other we have 8. The next we have 7. We have next for 6, and then we have 5. So we have to select 5 from 9. So this would be 15120 with we'll be using our calculator over here. Now in part 2, we have find how many of these 5-digit numbers are greater than 50,000 and even. So it has to be even and greater than 50,000. So we'll be using the even side over here. So a number which ends with 2, a number which ends with 4, a number which ends with 6, and a number which ends with 8. So we have our remaining 4. Let's just draw them. So if we have our 2 as the last number, now what can we have over here? We can have 5, 6, 7, 8, and 9 in both cases. So we have our 5 combinations over here, and we have selected 1 and then 2. So we are left with 7 combinations. So this would be 7, 6, and then 5. 7, 6, and then 5. This 5 will be multiplied by 7. This 7 multiplied by 6, and then this would be 5. And then this is, since it's fixed, so this wouldn't be multiplied. So this would be getting it as both our answers as 2100. And then here we'll have our options as 5, 7, 8, and 9 over here. And here we'll be having as 5, 6, 7, and 9. So 4 combinations over here and 4 combinations over here, and then 7, 6, and then 5. So we'll be getting our answer as 1680 over here. We'll be adding both, and we'll be getting our final answer as 3780. So this is our final answers. Now in part B, we have a team of 9 people is to be chosen from 6 doctors, 4 dentists, and 2 nurses. Find how many possible teams include at least 2 doctors, at least 2 dentists, and at least 2 nurses. Now we have a constraint of 2 nurses. So 2 nurses has to be necessary. Now we have we will be taking our dentist as DN and our doctors as DO. So let's just take two DNs, that is dentists, and five doctors, that is five doctors. And then another combination can be two nurses, three dentists, and four doctors. Another combination can be two nurses, four dentists, and three doctors. Now we can't have more than four dentists because we are limited with four dentists and two nurses. So these are the three possible combinations. So we'll be writing this as 2C2, since we have to select two nurses from two, and 4C2, 4C3, 4C4. Two dentists, three dentists, and four dentists. And then 5, 4, and 3 doctors. So this would be 6C5, 6C4, and then 6C3. So we'll be getting this as 36, this as 60, and this as basically 20. We'll be adding this up and we'll be getting our final answer as 116. So this is our final answer. Now moving on, we have our question 9, as the first three terms of an arithmetic progression are Lg theta squared, Lg theta powered 5, Lg theta powered 8. Now since it's an arithmetic progression, we will be having our common difference. Given that the sum to n terms of this progression is this, find the value of n. We need to calculate the value of n. For that, first of all, we need to calculate the common difference. For common difference, we need term 2 subtracted by term 1. Term 2 will be subtracted by term 1. So we have our term 2 as this will be coming over and this will be coming over. So this would be 5 Lg theta and this is 2 Lg theta. So we'll be getting our final answer common difference as 3 Lg theta. Now for the sum of n terms, we have our formula as n over 2. 2a is 2 Lg theta plus n minus 1 d. Our d is 3 Lg theta. And this Sn is given as 4732 Lg theta. So this would be 4732 Lg theta is equals to n over 2 4 Lg theta plus 3n Lg theta and negative 3 Lg theta. So this 2 would be multiplied over there and this would be 9464 Lg theta equal to n. This 4 Lg theta and 3 Lg theta would be cancelled out. So this would be Lg theta plus 3n Lg theta. This Lg theta and Lg theta would be taken as common. So this would be cancelled out by this. And we'll get our final answer as 9464 n plus 3n square. Now we can solve this as 3n square plus n negative 9464. You can use the calculator over here and get our n as 56. We're getting our n as 56. So this is our final answer. Now moving on, we have the sum is equal to 14196. Find the exact value of theta. So we'll be using this 4732 Lg theta. 4732 Lg theta is equals to negative 14196. This 4732 would be divided over there. We'll be getting our answer as negative 3. This would be Lg theta, and this Lg is removed as 10. This would be 10 powered, so this would be 10 powered negative 3 as theta. Our theta would be 0.001. So this is our final answer. Now moving on with the part B. The first three terms of the geometric progression are this. Determine whether the progression has a sum to infinity or not. For sum to infinity, it has to have an r lesser than 1. So let's just see if we have our r as lesser than 1. So for r, we'll be dividing term 1 with our term 2. So our term 2 is given as LG phi, and this will be coming over here. So this would be 3 LG phi. This LG phi and LG phi would be cancelled out. So this would be 1 over 3. So R is basically lesser than 1 over 3, and sum to infinity exists, since it will be diverging. This series is basically diverging series, which means the value would be decreasing as the series goes on. Now in part 2 we are given as find the nth term of this geometric progression, giving your answer in 3 powered a LG5, where a is the function of n. For term n we have the formula is a powered r, a into r powered n minus 1. We have our a as 3 LG5, we have our r as 1 over 3, and this as n minus 1. Solving this, we have our LG phi as something different. So this would be 3 as separated. This would be 3. And this would be 3 powered negative n positive 1. And this LG phi would be written as 3 is add, since 3 is multiplied over here, so this would be added over here. So this would be multiplied by 3 powered negative n plus 2. And this can be finally written as 3 powered 2 minus n. So this is our final answer. Our a is basically 2 minus n, function of n. Now for part 3, find the value of phi, given that the 20th term is 3 powered minus 18. So we have our 20th term as 3 powered negative 18. So 3 powered negative 18 is equals to LG phi 3 powered multiplied by 3 powered 2 negative 20. So this would be negative 18, and this would be divided over there. So this would be 1 is equals to LG phi, and we get our phi as 10 power 1. So our phi would be 10 simply. And I guess this is it. Now thank you for watching, and please do like, share and subscribe our channel. Thank you.